Okay, let's have a look at this question. We've got a quadratic multiplied by another quadratic to give me negative 15. And I ask you to solve this. This looks like an absolute nightmare of a problem that makes people want to quit maths. But I promise you, by the end of this video, you're going to be able to solve something like this fairly easily. The key isn't being a maths genius, but learning to see the hidden pattern that makes this super simple. So the most obvious thing to do if you saw something like this is to multiply this out, to use FOIL. Basically, that would mean you would do this times this, this times this, this times this, then this times this, this times this, this times this, and finally that times that, that times that, that times that. Basically, FOIL on steroids. This would give us a monster of an equation. If you multiply these two out, you get x to the power of 4. If you multiply this out, you would get x cubed. When you multiply that out, you would get an x squared term, and so on. The result is actually a quartic equation, an equation that has the highest power to 4. And solving a quartic equation is incredibly difficult. Nobody memorizes the formula for it. And this is where most people would get frustrated and think they're just bad at maths. But the truth is, they're just missing one simple shortcut. Remember, we want to work smarter, not harder. So let's look at the equation again. You've got x squared plus 5x, take 1 in brackets, x squared plus 5x plus 7 in the second brackets. I want you to ask yourself, is there anything that repeats in both? Is there anything that is common in both parts? And there is. Hopefully you could see that x squared plus 5x appears in both parts of this equation. And this is our key. So we could actually use substitution. We can make up a variable, which we're just going to call u. And we can say u is just x squared plus 5x. So in this equation, wherever I see x squared plus 5x, I could replace that with u, and that will make life a lot simpler. So let's do that. So we're going to replace that x squared plus 5x by u. So we would have u minus 1, and this x squared plus 5x also by u. So you would have u plus 7, and it equals to negative 15. Okay. And from now on, it should be pretty straightforward. So we would multiply this out. So you're going to do that times that first, which is u squared. That times that, which is 7u. That times that, which is negative u. And then finally, that times that, which is negative 7. And we're told it equals to negative 15. Okay, we have a quadratic. In order to solve a quadratic, we need to make it equal to 0. So we just need to move this negative 15 to the left-hand side. And whenever you move something across the equal sign, it becomes the opposite. So because it's negative 15 on the right, when you move it across, it becomes positive 15. So my left-hand side now is u squared plus 7u, take u minus 7, and instead of negative 15, we would have plus 15 on the left-hand side, and it equals to 0. Now we could collect like terms. So 7u take u, remember there's a 1 here, is positive 6u. So we would have u squared plus 6u, and minus 7 plus 15 is positive 8. So we have u squared plus 6u plus 8 equals to 0. Now this should be quite easy to factorize. We're just going to write out all the multiples of 8. So you could have 1 times 8 or 2 times 4. We want to choose the ones that add together to give me 6, positive 6. And 2 and 4 would add together to give me positive 6 if they were both positive. So that means our quadratic, we could factorize to u plus 2 as one of the factors and u plus 4 as the second factor, and this equals to 0. And now we know, using null factor theorem, if you've got two multiplications, two factors that equal 0, one of them has to equal to 0. So either this one has to equal to 0, so either u plus 2 equals to 0, or u plus 4 equals to 0. And if we rearrange that, that would mean that u equals to negative 2, or u equals to negative 4. But remember, the equation, we want to figure out what x is. U is just something we introduced. So we need to do one more step. We need to sub it back into our original substitution equation to figure out what x is. So u is x squared plus 5. So we're going to say that x squared plus 5 equals to negative 2, or x squared plus, so it should be x squared plus 5x, x squared plus 5x equals to neg 4. So remember, u was just x squared plus 5x, and it either equals to neg 2 or negative 4. So let's solve this. So again, these are quadratic, so we need to make them equal to 0. So we need to bring that neg 2 to this side. So that would mean we would have x squared plus 5x plus 2 equals to 0. Or we're going to bring that 4 to that side. X squared plus 5x plus 4 equals to 0. So let's work with this one first. So can we factorize this? We can't, because there's no factors of 2 that are going to add together to give me 5x. So let's use the quadratic formula. So remember, any quadratic equation could be written in standard form, which is ax squared plus bx plus c equals to 0. And if we did that, in this case, the number in front of x squared, the coefficient in front of x squared is 1. So a is 1, b is 5, and c is 2. Let me write out my quadratic formula, which is neg b plus or minus square root of b squared, take 4ac over 2a. And let's sub in our values. So we have neg 5 plus or minus square root of b squared. So 5 squared, take 4ac all over 2a. And that would give me negative 5 plus or minus 5 squared is 25. 4 times 1 times 2 is 8, and it will all be over 2. And we could simplify that even further, as 25 take 8 is 17. So we could say minus 5 plus or minus root 17 over 2. So that's two of my solutions. So either x equals neg 5 take root 17 on 2, or x equals neg 5 plus root 17 on 2. But we also get two solutions from this. So let's solve that. So that one was x squared plus 5x plus 4. So we could factorize this quite easily. The factors of 4 are 1 and 4, and 2 and 2. 1 and 4 add together to give me that 5. And they would both have to be positive, and they multiply together to give me positive 4. So we could write this as x, and our first factor would be plus 1, and our second factor would be plus 0. And then, using the null factor, we know that either x plus 1 equals to 0, so x has to equal neg 1, or x plus 4 equals to 0, so x has to equal to negative 4. So my four solutions, remember we have four solutions, are going to be x equals either negative 1, negative 4, so either that, or my said neg 5 minus root 17 on 2, or neg 5 plus root 17 on 2. Nice. Hopefully you feel good after seeing that. Well done if you were able to figure that out, if you were able to get all 4 of those solutions. Or well done if you're just able to follow through as well. You should feel good. It was a bit complex, but we got there with a shortcut. So if you found that helpful, let me know on the comment section, especially if you were able to solve it before I was. I would definitely love to hear from you. But remember, yeah, do all that good stuff. Comment, like, and subscribe. And the biggest takeaway I want you to take from this is maths is all about your attitude and your mindset. So whenever you see a intimidating problem, what I want you to do is take a breath, a step back, and then look for a pattern or a repeating piece. And maths is often designed to have clever solutions. And substitution is a super powerful trick that you could use. Remember, you don't hate maths, you just haven't been shown the secrets yet. Thank you for watching and see you next time.